Hello everyone, this is Group 10. We are working on a movie recommendation system using collaborative filtering. The team members of this group are myself, Dharmikkumar, Vijaykumar, Patel, Darshil, Maganbhai, Bhakhar, Gurneet Singh, and Wen Dong. This is an overview of our presentation. We will be going from the vision, system architecture to system demos, objectives, possible risks, and risk management, and in the end, summarizing the presentation. I will hand it over to my team member Darshil to take us through the rest of the presentation.
Hello everyone, I'm going to talk about what is movie recommendation system. It is a subclass of information filtering system. It will extract information from large amount of data according to items rating and users preferences. It gives a recommended list of movies and recommendation score according to movie which have been given by user as input. A recommendation system is mainly used in commercial purposes for targeting particular audience to subscribe channel and to increase watch time. The approaches which are mainly used for developing recommendation system are collaborative filtering and content based filtering. There are many other approaches like mobile, hybrid, multi criteria, session based, and risk awareness recommendation system. The vision of our project is to provide more relevant movies to users according to their preferences and ratings. Currently, there are approximately more than 5 lakh movies in the world, and to find out movies of particular choice is very difficult and also time consuming. But using this system, finding movies of user choice will become easy and quick. Apart from it, it is more beneficial to service provider because if people can find particular content easily on their website, the watch time and subscriber will also increase, and this system will give a personal experience to user by filtering their favorite movie channels.
The development of the system needs the implementation of various methods. The methods that we have used are KNN model. KNN means K nearest neighbor algorithm, which is a classification algorithm. For a certain element, this model finds its neighbor that have similar features to that element. As we can see in the diagram, the element W is more closer to the elements of X category as compared to the elements of Z or Y category. Therefore, according to this model, element W shares similarities with the elements of X category only. Next is the collaborative filtering. This algorithm is a user-based filtering algorithm, which means it makes the classification of elements based upon the user preferences. This algorithm generates recommendation based upon the common preferences between two users. For example, suppose we have two users. User 1 likes movie A and user 2 likes movie B. The movies are different but belongs to same category. Therefore, according to this algorithm, there are chances that user 2 may also like movie A and so forth is for user 1. Next we have used is the cosine function. This mathematical function is a part of collaborating filtering algorithm. This means this function is used to calculate the similarities between the two users. In case of movie recommendation system, cosine angle between two different categories of movies is calculated. It can be seen in the diagram. Hello and world belongs to two different axes. Now we have two vectors, one is hi world and other is the hello world. Less is the angle between these two vectors, more is the similarity between them. And the last is the KNN nearest neighbor selection. After the calculation of cosine function, we will know which user is most similar to which other. This algorithm assigns a value k to different users. The value is assigned according to the similarities. A higher value would be assigned in case of higher similarities, and a lower value for less similarities. In future, these values are used to generate the recommendation. This is the system architecture. You can see the various modules of the system which are present on the IBM cloud. The user will only have interactions with the application part of the system. The application module has a graphical user interface fabricated using HTML and CSS. After a user has made the request via this module, a request is sent to the Cloud Functions module. Cloud Functions is an IBM Cloud instance that provides functions to perform calculations. After which Cloud Functions read the recommendation function module, where the KNN model and collaborating filtering algorithms are implemented. You can also see that the dataset is required for the implementation of these algorithms. Later, as subpart, the process of matching, ranking, and prediction is performed, calculating the top n recommendations. As we can see, the calculated results are conveyed back to the recommendation module, which after processing are shown back to the users as final results.
Okay, now let's have a live demo about our project. Our project, as you may already know, it's a movie recommendation system. It's a distributed web application. Once we open the page of the web application, then we can say the user is quite straightforward. Here, we can input movie name, movie title, and then based on which it will recommend similar movies. Let's have a try. For example, let's input something. Okay, you can say in the drop-down list, it will list all the available valid movie titles that we can use as our input. It is to ensure that our input is valid. For example, let's select The Godfather, the movie, and then click recommend. Okay, here we have limited our recommendation to 5 movies. Uh, Basically, there are 2 columns. The first one is the title of the recommended movies, and the second column is recommending score, which reflects how similar or how much does the system recommend this movie. Okay, so this is a live demo. You can have a try by yourself. Thank you.
The objectives of the project. We wanted to filter the dataset, remove movies less than 50 user ratings. Then using the filtered dataset, we wanted to create a machine learning model, then generate recommendations from the trained model, and then development of UI where the user can input the name of the movie that it wants recommendations based on, and the model generate the recommendations, then deploying the developed system over IBM Cloud. The risks that we identified were user privacy issue. Users do not want some information to go public, such as like my name and stuff when I'm rating the movie. And then second risk was lacking cloud instances, whereby whenever a new feature is added, we might have to add a cloud instance, which is of course not generated automatically. So it might lead, if we just add the feature into the system and the instance is not there, it might not work well. Then we all know movies they're released on a regular basis, and user ratings keep changing over time. So due to this ever changing of data, it can be a risk if we continue using the same data set without updating it. Our recommendations might not be up to date. And lastly is less user ratings. If a particular movie has received less than 50 ratings, it might not go through the model. We came up with some solutions or strategies to overcome these risks that we identified. The first one being an interface between the user and the system to mitigate the privacy issue, such that things like when you're logging in, or that you use your user ID rather than the name. And also in the data set, we would be including like user ID rather than the name, to keep the name private, such stuff. And then we can be manually adding a cloud instance to keep the system up and running whenever a new feature is added. And for the ever-changing data, we can either regularly update our dataset, or we can be using a live dataset such that our recommendations are up to date. And lastly, for movies that receive less than 50 reviews, we can be giving them a sort of biased recommendation, such that someone inputs Black Panther, we can give them recommendations based on the title of the movie and the likeliness of how close it is to Black Panther's, a sort of biased recommendation, and also indicate that it's not as accurate as to keep the system working. To summarize the project was developed in agile methodology in two phases. We performed a number of tests. The tests we performed were usability test, conversion test, and stress test. And to manage the project, the project management was done in Jira, and to manage the different versions of the project, we used GitHub repository. Thank you, everyone. Any questions?